Welcome back, everybody, to Daily Math Concepts. We're continuing where we left off on the Add Math 2019 paper. We're at number 3. All right, so let's go. Number 3, let's go. So the question reads here at number 3. Question reads, so the question reads, the circle with center 1, -1 passes through the point 4, 3. Calculate the radius. All right, so we're asked to calculate the radius here. All right, definitely, let us say we have a circle here. All right, so that's our circle. That is our circle. And all right, and it is said that this is the center. All right, so that's the center. And the center is 1, -1. All right, so that is the center. We are now asked to basically, we're asked to find the radius here. All right, let's go. All right, so definitely we're seeing that the radius would be simply the length of this line from the center to where it passes to the point. So definitely we could label our points quickly, like label our points. Yeah, we don't have to, but it's okay. We could call this x1, y1. We could call this point here x2, y2. So in an effort to label that, we're talking about the radius. I'm just going to say the radius is going to equal to the root of all of this. All right, so it's going to be the root of 4 minus 1 square. So that is basically x2, x1. We're going to be adding that to 3 minus -1, and you square that, and that is y2 and y1. So that's what we have there. So basically, this is going to give me 4 minus the 1. That's going to give me 3 square. And this is going to give me a positive 4 square. So we're talking about 9 plus 16. Talking about 9 plus 16. And they take the square root of that. So basically, we're taking the square root of 25, and that is going to land us 5 units. So definitely the radius that we're looking at is actually 5 units long. And that would have taken care of that first question. The second part of the question, though, says write the equation of the circle in the form x squared plus y squared plus 2fx plus 2gy plus c. So basically, it's just the equation of the circle that we're dealing with. So we're dealing with the equation of the circle here, and we're going to carry everything on one side and let it equal to 0. But remember, though, that the equation of the circle, it's this idea, the equation of the circle. We'd have a x minus a squared, that is the x point, plus the y minus b square, and this would have been the y point at the center, and this is equal to r squared. So this is how it is written. We're going to be utilizing this and expand it, and then we're going to use that idea to link back to these. All right, so they want us to write it in that format, so we're just going to expand it value. So we're going to be having x minus a, and a is going to be 1, because remember, at the center it's 1, -1. This is our x, this is our y, this is what we call the a, and that we call the b, right? That's what we're referring to. So I'm talking x minus 1, right? So I'm going to have s minus 1 there, square, plus y minus, but guess what? This is also a minus, so I'm going to have a y minus -1. All right, there is a -1 there, so that we could just see what goes on. And then this is going to equal to r squared, but we just found r to be 5, so it's 5 squared. So I'm going to utilize this now to ride forward. Let us expand this. When we're expanding a binomial, we're squaring it. Basically, we'll have the x squared, -1 times x, x, and we double that up, so we'll get negative 2x. Then negative 1 square will give us positive 1. We'll get a y square here when we square the y. This is a plus 1 that we'll have here. So we'll get positive 2y when we expand that, and then we'll get a positive 2. So for persons who are wondering what's going on, and this is equal to 25, right here, remember 1 minus y minus 1 would have automatically become y plus 1. And when we square this, that's when we'll get the response that we got there. All right. All right. We're not done. We're not done. We need to get everything on one side. So, and we need to collect what we have to collect and, you know, organize it the way in which it ought to be. So basically then we'll have an x square here, and then I'm going to put the y square beside it. And then I will have a negative 2x plus 2y. Then this now will be, we'll subtract 25 from both sides. So I'm just going to write the final thing, subtracting 25 from both sides. So I'll write the final thing here. So I'll write the final thing here, which means then I'll actually have negative 23 here, and this is equal to 0. All right. So basically, write the equation of the circle in that format. That is the format right there. That next question says determine the equation of the tangent line. All right, so if I'm going to determine the equation of the tangent line, be advised that let's go back for the concept here. If we're going to look at the tangent line, so right where we have that here, we would have the tangent right there, right? So the tangent line would have been at right angle to the radius right there. There's a right angle there to the radius. So definitely we can, because we just need to find the gradient of the radius here. And after we find the gradient, we take the negative reciprocal of it to get the gradient for the tangent. So that's the point. That's the point. So finding the gradient of 1, negative 1, 4, 3. Let's go for the gradient of the radius first. So we're going to definitely need the gradient of the radius. All right, let's go for the gradient of the radius. All right, so let's go. So we're talking about the gradient of the radius. So I need to find the gradient of the radius. So the points that we have for the radius is actually this. So if I have those, then basically I could just say x1, y1, x2, y2. And so the gradient, I'm just going to call it m. We know it's y2 minus y1 over x2 minus x1. So this is going to equal to 3 minus 1 over 4 minus 1, and this is 4 over 3. So that's the gradient of the radius. So this is the gradient of the radius that we're talking right there. It's 4 over 3. Now, remember now that the tangent is going to be at right angle to the radius. So we want to make sure that we understand the relationship between perpendicular lines, right? A tangent is perpendicular to the radius. Therefore, the gradient of the tangent, we'll say the gradient of the tangent is simply the negative reciprocal. So we're talking about flipping that and turning the sign. So it's a negative reciprocal of the radius. And then remember, it passes through the point 4, 3. So therefore we could use this and just write it in the slope intercept form, and we're done. So basically what we're doing here, we're saying, okay, y minus y1 is equal to m, open bracket, x minus x1. And we could use this to write along. Y minus 3 is equal to m, which is negative 3 over 4. Open bracket, we have x minus 4. I'm going to, so we'll have negative 3 for x. Distribute the 4 inside, we'll have negative 4 times negative 3 over 4. And then we're going to be adding 3. All right. So this would have canceled itself there. So let us see what we really have. We'll have y, which is equal to negative 3 fourth x. And then now these will be a positive, right? So 3. and then there's another 3. So y is equal to 3 over 4 x, negative 3 over 4 x plus 6. So we're saying that is the equation of the tangent. That would be the equation of the tangent line to the curve. All right, that's the equation of the tangent line we're talking about. If we try to get rid of the fraction, here, if we try to get rid of the fraction here, some people don't mind having it like this. Multiply everything by 4. So you wouldn't say this would have been 4y is equal to negative 3x plus 24. This is the same thing as this, except the fact that this is in the slope intercept form, and this is not. Understand? So it's up to you. I kind of like the slope intercept form where y is by itself, because I'm able to tell gradient and y-intercept at the same time. All right. So with that said, that is question 3A. Question 3B will be coming up, where we'll be looking at the vector aspect of this. Thank you for watching, and subscribe to and like and share Daily Math Concepts. Thank you.